Section 8.2, adding and subtracting. Section 8.1, we did multiplying and dividing, and we figured out that dividing was pretty much the same as multiplying. So really, we just did multiplying in Section 8.1, and that was obviously easier than adding and subtracting is. The notes today will be pretty lengthy. There's a lot of stuff going on in each one of these problems. Yesterday, I started losing people about the 25-minute mark, and then we got refocused back in. They ended up doing pretty well with it. So I'm just telling you it's difficult, not to say, oh, don't even bother trying. I'm telling you it's difficult to prepare you. You can do it. You just got to try, pay attention. So what does it mean adding and subtracting fractions? Last time we started off with two fractions from elementary school that we multiplied. And I know you can cancel stuff there before you multiply, but I want you to go through the step up here. What do you do when you multiply two fractions together? Yeah, just simply multiply across the top. And in this case, we would get what? 6 over, which is 1/2. So did we care about the fact that we didn't have the same number on the bottom? No. And of course we do when we would try to add those exact same fractions. So can we add those? No, and the problem is that the last 6-7 years of your life since you started having fractions, you just typed 2/3 plus 3/4 in your calculator and it did all that for you and gave you the answer. That works well for fractions without variables in it, but unfortunately today they will have. So we've got to kind of go back to getting that common denominator. So you have to figure out what's the smallest number that 3 and 4 go into, and that is 12. So what I tell the kids to do is make 2 new fraction bars with your new denominator in there. Put a 12 under both. And these, I know I always stress to do the same thing that I do, but today it's extra important that you make those new fraction bars, that you solve it the same way that I'm solving it. If you try to cut steps today, it'll be bad. So then we look at the denominator that we had, which was 3, and we look at the denominator that we need it to be. These are the only two things that we care about right now. It does not matter what's on top, and that'll be extremely important later. And what do you take times 3 to get 12? So you take the top times 4. So this should be review. So you'd get 8 for that one. And what do you take times 4 to get 12? So you take the top times 3, whatever it is, and you would have 9, and then you could add those together. Now they do have a common term. So that's what you're doing today when you're adding and subtracting these fractions, only they're rational expressions, meaning you're going to have variables in there. So we will just go through examples, a lot of examples to prepare you for some homework problems, hopefully. But first, let's look at 450 at the bottom, example 1 there. The first few examples we'll do, we won't even worry about adding and subtracting fractions. We'll just worry about getting a common denominator. So if you started with 18r squared s to the 5th, that was your first one, and 24r to the 3rd st squared. And 15 s to the 3rd t. So you could pretend those are your 3 denominators, even though right now they're not. They're just 3 expressions that we're going to simplify or find the common number. So you always look at the numbers first, the coefficients out front, and you have to find, just like we did in that easy example, the smallest number that 18, 24, and 15 all go into. Most students just choose to do trial and error in your calculator until you figure that out. I'll show you another method that you can use. I'm not even going to show you that method right now because I don't hardly know anybody that actually uses it. It's just basically, so grab your calculators, start typing in some numbers, figuring out what number 18, 24, and 15 all go into. Some people choose to multiply two of them together and then see if the other one goes in. Yeah, but that's going to be way higher than the actual number. Or you could take 18 times 4, see if you get a number that the other two go into. You found 360 so far? Yeah. Anything else? We agree? 360? That is correct. 360 is the smallest number that those three go into. So 360 is your number. Then you look at the letters, and you start with the first alphabetical letter, which is any of the three. You look for the first letter in the alphabet, which is what in this case? R, and then you take the biggest one. What's the biggest R you have? R to the third. Next would be S, the biggest one. S to the fifth, and T to the second. That would be your common denominator if you had to finish this problem. Right now we're just finding the least common multiple. That's what it is. Let's do one more. 12a squared b to the fourth. It's 27ac to the third. And 18a to the fifth b squared c. So the smallest number that 12, 27, and 18 all go into. $324. We got 216. Either one of those are it. What? 120? They all go into 120? She already said 216. Because you're the smaller one. 108. 108. That is correct. So 108. Now I will show you on this one the other option to figure out what goes in there. And you just do a factor tree. So 2 out of 12 would leave 12 divided by 2 is 6. Divide that by 2, and you get 3. So how you would write that is 2 squared times 3. And you do the same thing for 27. Can you take a 2 out of 27? So you'd go to a 3. Take a 3 out. So you'd have 3 times 9 and 3 and 3. So that one would be 3 to the third. And you do the same for 18. Take a 2 out and you have 9. Split that up and you'd have 3 and 3. So that one is 2 times 3 squared. So you do the same thing you do with the variables if that's the method you choose. So what's the first number that we see? 2. What's the highest one? 2 squared. So for your LCM, which is what you're finding, you have 2 squared, and then the next number you have is 3. What's the highest? 3 to the third. So if you type that in your calculator, it will tell you 108, and that is correct. 4 times 27 is 108. So you can use that method if you want to. So 108 is the number, and then you look at the letters. What's the biggest A? A to the fifth, B to the fourth, C to the third. And that would again be your common denominator when we get to those problems. So again, all of these are monomials. Each one is just one term. We also have the polynomials. That's where it gets pretty the problems get pretty long and drawn out. But we'll start off just finding the common denominator. P to the third plus 5p squared plus 6p. That's your first one. P squared plus 6p plus 9. Is your second. So before you can do, so there's an added step here. You can't just go straight to the common denominator. First you have to factor everything. What's the first step of factoring? Common terms. Is there a common term in these three? A p. So you take the p out front. And what would be left in the first term? P to the third divided by p. It leaves you with p squared plus 5p plus 6. And now that is a trinomial. So I would use quad 3 there. Figure out what the factors are. Or you can tell me factors of 6 that add up to 5. 2 and 3. So p plus 2, p plus 3. I bet we beat the quad 3 people. Same over here. Factors of 9 that add up to 6. What? P plus 3, P plus 3. So those two are now factored. So here's how you get the common denominator. First, if there's ever a letter or a number in the front, that's the first thing you're going to include. So you've got a P here. What's the highest just plain P that you see? It's not P plus 3 or P plus 2 or whatever. Just P. So that's part of your common denominator. I have kids cross it off. Everything that you see here in this line has to be accounted for in the common denominator. So once you've accounted for something, cross it off. So the next factor that we see is P plus 2. So that's got to be in there. Are there any P plus 2s over here? No, but you still cross this one off. That's now accounted for in the common. What's the next one we see? P plus 3. That accounts for this one and one of these. Okay? So what do we still have left? P plus 3. And that would be your new common denominator. That would be what would go under the new fractions. It's just the rule. Another way to look at this, which I did yesterday for some kids, and I'll write it down below. You had the same problem, P plus 2, P plus 3. And then how's another way you could write that, since there's two of them? P plus 3 squared, since there are two. So back to what we did when we just had the single letters up here. What did we look for in the A's? The highest one. So you're going to do the same thing down here. We took the P for the LCM. The P has to go in there. Are there any other plain P's? For instance, if you had P to the 4th right here, then you would take P to the 4th. That would account for both. P's all we got, so we cross that one off. And then we have P plus 2. So we cross that one off. Now, we have a P plus 3, so you look across your line, what's the highest P plus 3 that we have? P plus 3 squared, so that's what you would put here. And that would account for everything. The reason I want you to do it this way, if you can, is because it's easier if your common denominator doesn't have any P plus 3 squareds in it. If you haven't listed out each one of them, none of them being squared, you'll find that to be easier in the long run. So, like I said, what you do, P plus 3 goes here. That accounts for these two. So it can only account for one out of each denominator that you have. We'll do a lot more examples Just hang with me. Another one just like that. 2x to the third minus 5x squared minus 12x is your first one. K to the third minus, or x to the third minus 8x squared plus 16x. So what's the first step we do on these? Is there a common term in the first? So we can take an x out front, just like on the last one. And what would be left? 2x squared minus 5x minus 12, and then we would factor that. And that one you're probably going to need quad 3 to get a number out front. Everybody got it? X minus 4 and 2x plus 3. Okay? That's another thing to keep in mind. Nobody's ever had quad 3 before you guys, so you think this is difficult. Imagine all the classes before you that had to do that part also. So we got that factor. Is there a common term in the next one? Take an x out again. So we have x squared minus 8x plus 16. So this time we need factors of 16 that add up to 8. X minus 4, x minus 4.
Okay, so there's negative and like the 8 that can go from the negative 3.
You always look here first. This means same as the first, so they're both minus. So least common multiple or common denominator that we're looking for. Do we have anything out front of the parentheses? Okay, so what's the highest just plain x you see? X. So this x that you put in the common denominator takes care of both of those. Those are both accounted for. If one of them had been x to the third, then that's what your common would be. So then we have x minus 4. We know that has to be included. That accounts for this one and this one. Those are both now accounted for. So what do we still have? And it doesn't matter order. Some said x minus 4, some said 2x plus 3. Doesn't matter. I try to keep the same ones beside each other. Just, I don't know why, but so that's the way I do it. And 2x plus 3. That would be your common denominator. So let's go ahead now and work on the full process.
What if you had a number out front where the x was, how do you decide? You just take the bigger thing.
Right. You find the smallest number. Like if you had a 2 and a 4, you take the smallest number that they go into, which would be 4. If you had a 3 and a 4, you take the smallest number they go into, which would be 12. And I think we'll have some examples of that, hopefully.